Okay, here we are with chapter 15, talking a lot about inheritance, polymorphism, uh, virtual objects, abstract objects, and I think I'm going to start out now with some UML. UML is important, and I know that in some of the labs I've been using UML, and sometimes they're not coming across as clear. I know that there are some colleges and universities in which they will spend a whole 15-week semester teaching their software engineering students UML. I know Drexel does that, Penn State does that. So here we have a little mini lesson in UML because, as you know, I'm using it quite a bit in the labs. So I'm creating 3 objects for this next lecture demo that we'll do in code blocks. A point object, which is just an XY Cartesian coordinate point. And then we'll have a circle, which also has a point, that'll be its center, and a radius. And a cylinder, which also has a point for its center, radius if you will. Then we got the, like I said, the radius, that will be the top and bottom parts of the circle, and then we have the height. So let's start with point. Okay, remember the first box of the UML is the name of the object. And many times the name is going to have little variations on it in the future lectures that I'm going to show. Is it abstract? Is it an interface? Is it inherited from something? Is it virtual? So you'll see that right now. This is just the name, but depending on how it appears, the UML reader will say, aha, I see what this is going to be when it grows up. Okay, so first things first. Right here, we'll have our X and our Y. So they will be private with the minus. X will be an integer coordinate point, and Y will also be an integer. And then we have our methods. So obviously we have a public point default constructor and a public point which will have an X and Y coordinate, X of type int, Y of type int. Okay. Now when we get to the coding, I'm going to show you a really cool way to blend these in once. Instead of writing two separate constructor objects, one will be a default, and masked within it will be, if someone decides that they want to put some values in, they can do it. If they don't put it in, it'll behave as a default. If they do, then the numbers they put in will override that. Okay, so here's the point. And then we can say setters and getters. And many times if you just say setters and getters, the software engineer knows what to do and they can skip writing this out. But I'm not going to skip it because you're still in the learning phases of UML. So let's see, let's do the setters. So setters don't return anything, they are public, and I will say set X, and we will give it X as an integer, and since it's a setter it doesn't return anything. And let me copy paste this because I'm lazy, and we'll put it right here, and this will be the set Y. And then we'll also have Y being set. That's the setters. And then down here will be the getters. So let's see, that'd be public get X. We don't give it anything, but we are expected in return an integer. And remember, in C++, you can declare it as constant. And since I always joke to my students that UML stands for Unified Modeling Language, and it's not unified, it doesn't model anything, and it's not a language. So therein lies the joke of it. If these are constant, remember, getters can be constant because we want it to be clear that it's not going to affect anything inside this object. Because if we have these public methods, the coder can do anything that they want to jam up the inner workings. It's like, no, like a bank robbery. Go in, go out, nobody gets hurt. Go in, get the X, go out. So you might see const on the side like that. All right, again, since UML is fluid and again, not unified in my opinion, then here the const could be just about anywhere. So we could leave it there as const. I could put a dash there, maybe a colon, but I think this is it. Oh, and a print method. some public, it'll print the details again, void, and it really doesn't return anything. It'll print it out from inside, and again, we could call it a const if we want, and we can have a toString if we want. toString, nothing goes in, and out comes a string. Now, we talked at last lecture about overloaded operators, and we overloaded the pre and post increment and decrement operators. When we get to the coding portion, I'm going to show you a way in which we overload the output stream operator, that less than symbol, and we're going to be, in a sense, that will be our new toString, but we have to introduce a new type of friendship with the output stream, and it actually is called the friend operator, the friend class, which you may have read about in the previous chapter. We didn't discuss it in the labs, but you'll see it come up here. Okay, so this is all I want to do for the point object, and I can steal some of these ideas for the circle. The circle also requires an x and a y, but the circle has something else. It's got a radius, so spell it out as radius, and here the radius can be of type double. And again, we have our constructors, a circle constructor, which has nothing, so x and y are 0, and the radius is 0, so that really isn't even a circle if it's got no radius. It's nothing more than just a glorified point. And here's circle, and why don't I kind of get lazy here? I'll steal all of these and paste. Okay, so circle, and same parameters here, x, y, but now we've got the radius, which is of type double. Okay, setters, set x, set y, and now we've got a radius to set. Set radius, and radius, I can say R for radius of type double. Again, it's just an input variable type, taking our information into the function and setting, in this case, the actual word radius. Okay, getters, get x, get y, and public get radius, and it's going to return a double. And because we are a circle, we can also get area, get diameter, right? I know it's nothing more than twice the radius, but sure, why not? It's a parameter of the circle. And get circumference. So all of those are void doubles. There. There. And there. And the print methods. Print and toString. Okay, so let me kind of move that up so it doesn't split on 2 pages. And of course, I'm going to post this to Blackboard so you have it. And that's the circle. Cylinder. It's going to have pretty much everything the same here. Some x and some y coordinate. But now it's got a height. Height of type double. All right, good. And now here are all the private methods, or excuse me, the public methods. Put them there. A constructor, calling it cylinder. Whoops. Okay. And same deal here with all those parameters, but now we have to add height of type double. And I now have to widen this table. Come on. There we go. All right, all the setters, set x, set y, set radius, and now set height. And that would be using an H for double. The getters: get x, get y, get radius, get height. And while I'm typing this, let me just say that, as you know, a cylinder is a three-dimensional object. It's a can, any kind of a cylindrical object like a battery or any of those shapes. So we have a radius and a height, but we really don't have an area. We do have surface area, right? How much paint it takes to paint that can. And we don't have diameter and circumference, but we also have the volume, right? And what is that? Pi r squared h. So there's the volume. Okay, so we've written these objects, but I can say that all circles are cylinders with no height, and all points are circles with no radius. And because of that, these can inherit. Circle, look at how much duplicity is here that's up here in point. Why not inherit? So that's why I have this open here on the side. I'm going to grab a symbol here and draw an arrow up like that. And in UML, that means my circle will inherit from my point. So everything that's in the point, the circle knows about. So circle at this point doesn't need x and y. Let me, let's see, what's a good way to do that? Can I go here and change its highlight? Why don't I highlight that in yellow? And also, I'll strike through. Okay, we don't need that. The circle object, its default constructor is 0, 0 for the point and 0 for the radius. And we have this information here. What we're going to do, since it inherits from circle, it doesn't say it here, but when we write code, we're going to write it specifically that says when we construct the circle, we're also going to wake up the radius to say, hey, add your integer, add your x and y information because we're sending it to you. Okay, I don't need set x and set y anymore because since I am now a child of the point, I know about them. And the get x and get y I don't need anymore. Now, the printing. This information is specific to the point, and so is the string. So I could have these and I would overload them because I want to print more than just the point information. So I'm going to keep these here. These will be overloaded operators. Okay, so it looks like I'm not going to get it all on one page. I wonder if this arrow will let me do what I want to do. Can I draw it to there? Not really. Okay, but you get the idea that if these were connected, let's see if I can't get rid of that. No, it won't let me. But this would then connect to this box up here. Again, the cylinder has everything about the circle. We don't need this. The only thing new that a cylinder has that a circle and a point doesn't have is a height. Okay? Again, the cylinder has all of this information except its height is unique. It doesn't need to know about the radius or the x and y. One strike through. These getters we don't need because we inherit from them. But get height, get surface area, and get volume will be different. And again, we have the print and the toString. So this is my mini video lecture that other universities will spend, like I said, a whole 15-week course just studying. It's not trivial for sure. There's a lot to it. But as a blueprint, you can use it in any language that you are working with, and it will tell you precisely how you want to construct it. Some languages, the data type comes afterwards, like Visual Basic. In some languages, the data type is not known. It's assumed until you put stuff in, like Swift for iOS programming. But regardless, this is a great blueprint for no matter what language you're working in. Okay, so I hope that kind of helps a little bit with when you get your labs, that you can see how we built these. Okay, so I'm going to save this document, save this video, post it, and then we're going to build a point object, a circle that inherits from point, and a cylinder that inherits from circle. And we'll see how they all come to play. Okay, wait for the next lecture now.